Good morning, one and all. Today topic is normal forms. So, what is the use of normal forms? So, normal forms are simplify complex expressions, making them easier to understand and work with. Okay. So here, two type we learn about two types of normal forms: disjunctive normal form and conjunctive normal form. So, disjunctive normal form, in shortcut DNF, and conjunctive normal form and CNF. Okay, so disjunctive normal form is defined sum of elementary products. Sum of elementary products. So what about elementary products? So elementary products, if P comma Q are two propositions, the conjunction of variables and their negations in a formula is called elementary product. The conjunction of variable and their negation in a formula is called an elementary product. If P, Q are two propositions, the possible elementary products are P, Q, negation Q standing alone are a elementary product, and conjunction of P comma Q and conjunction of P negation Q, negation P and Q, P and negation P, Q and negation Q. These are all possible elementary products for given two formulas, two variables. Okay. So next one, principal disjunctive normal form. So principal disjunctive normal form, in shortcut PDNF. So principal disjunctive normal form is defined sum of min terms. Sum of min terms. So what about min terms? So min terms is for a given number of variables, min term consisting of variable or its negation, but not both. That means if given two propositions P comma Q, then the valid min terms for two variables are conjunction of P Q and conjunction of P negation Q, conjunction of negation P Q, conjunction of negation P negation Q. These are only valid min terms for given two variables. So min term consisting of variable or its negation, but not both. But not both means in a conjunction variable and its negation, it is not represent a min term. That's why here it is given in invalid list. Okay, P and negation P, Q and negation Q, these are not min terms. These are elementary products but not min terms. Okay, so for example, P or P and Q is a compound statement. So obtain PDNF from this compound statement. Okay, obtain PDNF from this compound statement. So here you observe P. P standing alone is an elementary product and P and Q is an elementary product. So it is in the form sum of elementary products, which is DNF, not PDNF. Now we convert the DNF form into PDNF. So we change this elementary product into min term. Okay, we change this elementary product into min term. So by applying the equivalent formulas, in this case we replace in place of P the equivalent formula by idempotent law. P and true is equal to P. Sorry, not idempotent law, identity law. P and true is equal to P. Okay, so why we replace uh, P and true means it is an elementary product. It is not a minterm. Minterm means minterm consisting variable or its negation of given number of variables. If two variables is given, each minterm consisting of those two variables. Okay, either it is in variable or it is in negation. Okay, now here in this compound statement two variables are there, p and q. In this it is a minterm because in this p q both variables are present, but here p is an elementary product but not it is minterm. So we need to convert given compound statement into PDNF. So PDNF is defined sum of minterms. So now we changing the elementary product into minterm. Okay, that's the reason we replace by identity law in place of P and T. So in this conjunction we miss the variable Q. So by the negation law, we write Q or negation Q is equal to true. From negation law, we write from negation law, which variable is missing, we write negation law for that variable. So P and Q or negation Q or P and Q. So here and R and R and R. So two different symbols. Then we apply distributive law to this form. Here we consider A, B, C. So this is in the form A and B are C. Now we apply distributive law. A and B or A and C. Okay. So in place of A, P, in place of B, Q. So P and Q are P and negation Q by applying distributive law or P and Q. Okay. Here first term and last term. First term and last term both are similar. By applying idempotent law, the what is that law? P R P is equal to P. P R P is equal to P. By this law, we write P and Q, P and Q or P and negation Q. See here, sum of minterms, sum of minterms. So this is in PDNF. Okay. Now a same example we explain with a truth table. How we write minterms by using by construct truth table for given compound proposition. Uh, Let me know now. By using truth table, here we consider true cases. In this truth table, we consider truth cases to take minterms. Here, T, true value stands for the variable and false stands for the negation of variable. Okay. First, we construct truth table for given compound proposition. For given compound proposition, for given compound proposition, for given compound proposition, here we have two variables P and Q. If two variables are given, the truth values are 4. For P, true, true, false, false. For Q, true, false, true, false. Okay. Then we consider take so P and Q, P are P and Q. So by the rule of conjunction, both P and Q is true, then P and Q is true. So for first case, the truth value is true. In remaining cases, the truth values are false. So for compound proposition, P are P and Q. The rule of disjunction is when P is P and P and Q false, P are P and Q is false. Otherwise, it is true. So we take false cases for P. Third and fourth cases are false. In third and fourth cases, P and Q is also false. So the compound proposition truth value is false, false. In remaining cases, true, true. Okay. So now we consider min terms for this truth table. We consider truth cases. How many truth cases are there? Two truth cases. For these two cases, we consider min terms. Here we consider true stands a variable and false stands negation p. So true, true. In first case, truth values are true, true. That means the first min term is conjunction of p q. Okay, conjunction of p q. In second case, true, false. That means conjunction of p and P and negation Q. So Q truth value is false. So negation Q, conjunction of P negation Q. So PDNF means sum of min terms. So P and Q or P and negation Q. So this is about DNF and PDNF. Okay. Now we discuss about conjunctive normal form. Conjunctive normal form. Conjunctive normal form define product of elementary sums. Product of elementary sums. Product of elementary sums. So what about elementary sums? Elementary sums is defined disjunction of variables and their negations in a formula. Okay. For example, P comma Q are two variables P, Q, negation P, negation Q standing alone are elementary sums, and disjunction of PQ, PR negation Q, negation PRQ, negation PRQ, PR negation P, QR negation Q, etc. are possible elementary sums of P comma Q. Next one, principal conjunctive normal form. PCNF. So PCNF is defined product of max terms. So max term means for a given number of variables, max term consisting of variable or its negation, but not both. That means in a max term, if P comma Q are two variables, the valid max terms are PRQ, PR negation Q, negation PRQ, negation PR negation Q. So invalid max terms are PR negation P, Q or negation Q. So variable or its negation not consisting in a max term. It is not a max term. This is invalid max terms. Okay. So PCNF means sum of max terms. Okay. For example, PCNF means product of max terms. For example, we consider a compound statement P and P or Q. Here P is a elementary sum, PRQ is a elementary sum. So product of elementary sums. So this is in CNF. Now we convert CNF into PCNF. Okay. So in place of P, we replace P or F. So here Q variable is missing. For this we write P or F is equal to P by the equivalent formula. P or F is equal to P. So that's why we replace in place of P, P or F and P or Q. So in next step we replace Q and negation Q by negation law we replace in place of F Q and negation Q and P or Q. So now we apply distributive law. Distributive law for this statement P R Q and P R negation Q and P R Q. First term and last max term are similar. So by the idempotent law, we write PRQ and PR negation Q. So product of max terms. So this is in PCNF. So here we note that every PCNF is a CNF, but every CNF is not a PCNF. Same like that, every PDNF is a DNF, but every DNF is not a PDNF. Okay. So now we prove the same example by using truth table. In PCNF, we consider false cases. Okay. Here T stands for negation of variable and false stands for the variable. Now we construct truth table for given compound proposition. So the given compound proposition have two variables. So now we construct for P, the truth values are true, true, false, false. For Q, true, false, true, false. For disjunction rule is both PQ are false, then PRQ is false, otherwise it is true. So both PQ false case is fourth case. In that case, the truth value is false. In remaining cases, true. And then compound statement P and PRQ. So rule of conjunction is both P and Q are true, then their conjunction is true, otherwise it is false. Now we check P, in which cases P is true. First and second cases P is true. So in these cases PRQ is true for two cases, first and second cases. So the truth value is true, true, and remaining cases false, false. These are the truth values for given compound proposition. Now we consider max terms from this truth table. We consider false cases, third and fourth cases. Okay. So here T stands for negation of variable and false stands for the variable. So for third case, the truth values are false and true. False means negation P, true means Q. So the first max term is negation P or Q. In third case, false, false. So P or Q. Okay. The max term is P or Q. So product of max terms negation PRQ and PRQ. So this is in PCNF form by using truth table. Okay. So now we solve problems. First problem, obtain DNF and CNF of disjunctive normal form and conjunctive normal form of P and P implication Q. So first we eliminate by implications by using equivalent formulas, and then negations by using negation law and De Morgan's law. Then we apply associative law or distributive law. Then finally we get disjunctive normal form for the given compound statement. Okay. So for given compound statement we have implication. So first we replace implication by equivalent formula. negation P or Q. Okay, here P and negation P or Q. Now we apply distributive law. So P and negation P or P and Q. So sum of elementary products. So sum of elementary products which gives disjunctive normal form. Now conjunctive normal form. Consider the given compound statement P and P implication Q. We replace equivalent formula for P implication Q, negation P or Q. Here P is an elementary sum, negation P or Q is an elementary sum. So product of elementary sums which gives conjunctive normal form. So this is a CNF. This is in CNF. Okay. Second one, obtain disjunctive normal form and conjunctive normal form of P implication Q and negation of negation Q or negation P. So first we eliminate implications by replacing equivalent formulas. For P implication Q, the equivalent formula is negation P or Q. Okay, we replace in place of P implication Q, negation P or Q, and so negation Q or negation P. Here we apply De Morgan's law. Here we apply De Morgan's law. So De Morgan's law is negation of P and Q is equal to negation P or negation Q. Okay. So here we apply De Morgan's law. Negation of negation Q and P. Negation of negation Q and P. By double negation law, so P implication negation P or Q, and by double negation law negation will be eliminated, so remaining Q and P. Okay. Now we eliminate implication. So implication equivalent formula is negation P or Q. In place of Q, this term will be here negation P or Q and P. Okay. So this is not in DNF. Now we convert this compound statement into disjunctive normal form. That means sum of elementary sums. So negation P is an elementary product, and here it is elementary sum, and here it is an elementary product. Now we change this statement into sum of elementary products. So here we apply distributive law. A, this is of the form A B and C. A or B and C. So the formula is A and C or B and C. Okay. In place of A, negation P and C, Q and P, or in place of B, Q and P. Okay. So negation P or negation P and Q and P, this is an elementary product, or here Q and Q by idempotent law, Q and P by idempotent law, P and P is equal to P. By applying idempotent law, we write Q and Q is equal to Q. Okay. So negation P or negation P and P or Q and P, sum of elementary products. So which is in DNF. So next one, CNF, conjunctive normal form. So now we express the given compound proposition into product of elementary sums. Here also we first eliminate by implications or implications. In this given statement we have implications. Implications are replaced by an equivalent formula negation P or Q, and now here we apply De Morgan's law and negation, double negation law, negation of negation eliminated by double negation law, and here also we apply equivalent formula negation P or Q. In place of Q, negation P or Q and P. So this is negation P is an elementary sum, negation P or Q is an elementary sum, but Q and P is not an elementary sum. So here we apply distributive law to convert this compound statement into product of elementary sums. Okay. So here negation P is A, negation P or Q is B, and negation Q and P is C. So this is of the form A, R, B and C. So now we apply distributive formula A, R, B and A or C. So in place of the negation P or in place of the negation P or Q and negation P or Q and P. Okay. So negation P or P, negation P or negation P by idempotent law, negation P or Q and negation P or Q and negation P or P. Here again we apply distributive law. Negation P or Q and negation P or P. So product of elementary sums which is in CNF. So this is about DNF and CNF. Okay. Now another problem is PDNF without using truth table and using truth table. How we find given compound statement can be expressed in PDNF without using truth table and using truth table. First one, without using truth table. The given compound statement is P implication Q. So now we replace implication by negation P or Q. So negation P, Q are elementary products but not min terms. So PDNF means sum of min terms. Now these elementary products are changing into min terms. We replace in place of negation P and T, Q and T. So here Q variable is missing and here P variable missing. So in place of T, we replace Q or negation Q. Okay, negation P and Q or negation Q, or Q and P or negation P and R. So we apply distributive law. Here also we apply distributive law. Negation P and Q or negation P and negation Q or Q and P or Q and negation P. So negation P and Q or negation P and here we apply commutative law. We write P and Q or negation P and Q. Here first term and second term are similar. By idempotent law we write negation P and Q or negation P and negation Q or P and Q, sum of min terms. So which is in PDNF. Now we find with using truth table. So P, Q, P implication Q. So here two variables are given. So we have four truth values. For P, true, true, false, false. For Q, true, false, true, false. P implication Q. So by the rule of implication, when P is true and Q is false, the implication will be false. In remaining cases, true. So true, false, true, true. So here we consider true cases. Here from this truth table, we have three min terms. Those min terms are From first case, true, true. True, true means P, conjunction of P, Q, P and Q. So we consider from second case, P truth value is false. So we take negation P, Q truth value is true, and Q. So conjunction of negation P and Q. Third min term is both P, Q are false. So negation P and negation Q. So these are min terms from truth table. So PDNF means sum of min terms. Now we write P and Q or negation P and Q or negation P and negation Q. This is the required PDNF form for given compound statement. Okay. So next one, obtain PCNF of negation P by implication Q without using truth table, with using truth table. Without using truth table, we find by applying equivalent formulas. So for by implication, the equivalent formula is P implication Q and Q implication P. Okay. So by for implication, the equivalent formula is negation PRQ and negation QRP. Then we apply negation. So negation of negation PRQ or negation of and becomes R. Okay, negation of and becomes R. So negation of negation Q or P. So negation of negation P, P and negation Q or Q and negation P. So sum of this is in sum of min terms, but we need to changing into product of elementary sums. Okay, so this is in PDNF form, but now we changing into PCNF. This is sum of min terms, but we need to change into PCNF. We apply distributive law. So P and negation Q are Q. So A, let it be A, B, C. So this is in the form A, R, B and C. So A, R, B, P and negation Q are Q and P and negation Q or negation P. Again we apply distributive law. P R Q and negation Q R Q, P R negation P and negation Q R negation P. So negation Q R Q, P R negation P gives truth values. Okay. Now we replace true for these statements. So P and true by identity law gives P, that means PRQ, and true and P gives P by identity law. So here negation Q or negation P, product of max terms, which is in PCNF. Okay. Now by using truth table, we first construct truth table for given compound proposition has two variables P, Q. P has 4 truth values, Q has 4 truth values. So P truth values are true, true, false, false. Q truth values are true, false, true, false. By implication, the rule of by implication is both P and Q have same, then the truth value is true. Otherwise, it is false. So both P, Q truth values are same in first case and fourth case. So in these two cases, the truth values are true. In remaining cases, false. Okay. Negation of P by implication Q. The rule of negation is true becomes false, false becomes true. So the truth values of this connective false, true, true, false. Okay. Now we consider max terms for this truth values. So we consider false cases. How many false cases are there? Two. That means we have two max terms. Okay. So in PCNF form, true stands for negation P, false stands for, so in first case P, Q truth values are true, true. So true stands for negation. So we consider disjunction of negation P, negation Q. So F stands for variable. So disjunction of P, Q. So the max terms are negation P or negation Q, P or Q. So PCNF means product of max terms. So negation P or negation Q and P or Q. So this is about normal forms. Thank you.